Hello everyone, my name is Diksha and I am from the Bodhi Academy. Today I am going to cover the last chapter from 12th standard chemistry, that is chemistry in our everyday life. So chemistry in everyday life is basically what role chemistry plays in our life, in our day to day life. What is the role played by chemistry that we are going to see here. So let us start. First of all, we will see drugs and their classification. Now, drugs are classified on the basis. Okay. Now, there are four bases on which they are classified. So, first of all, they are classified on the basis of pharmacological effect, meaning what effect they give. So, this is based on pharmacological effect, and it is useful for doctors because it provides the whole range of drugs available for the treatment of a particular type. For example, analgesics have pain killing effect, antiseptics they kills or stop the growth of microorganism. Then antipyretics lowers the temperature of the body. Then antibacterial, antifungal, they will reduce the allergy or infection. So this classification is based on the pharmacological effect. Second classification, it is based on drug action. So drug action, it is based on the action of a drug on particular biochemical process. For example, all antihistamines inhibit the action of the compound, and antihistamine which causes inflammation in the body. So there are ways in which the antihistamines can be blocked. So this is about the basis of drug action. Then on the basis of chemical structure. So this is the third category, which is classified on the basis of chemical structure. So in this way, they share common structural features and often have similar pharmacological activity. For example, if you have sulfonamides, they have common structural feature. So this is if you have this structure, they come under sulfonamides. Okay, S with 2O and NHR. Then last is on the basis of molecular targets. Now this is basically this is the way in which drugs interact with biomolecules such as carbohydrates, lipids, proteins and nucleic acids, and these are called as target molecules or drug targets, and this is based on the molecular targets, which is useful classification for medicinal chemists. Then drug target interaction. Now the drugs which we take, okay, to cure the particular disease, how they produce the effect of the drug in our body. So that is basically depend on the drug target interaction. So in that we will see how the enzymes and receptors play important role over here. So proteins which perform biological the role of biological catalyst, they are called as enzymes, and which are crucial to carry the communication system in the body, and they are called as receptors. So here they both plays important role in order to carry out the interaction between drug and the target molecule. So here enzymes as a drug targets. Let us see catalytic action of enzymes. What happens here? The function of enzyme is to hold a substrate for a chemical reaction. An active site of enzyme hold the substrate in a suitable position. Then substrates bind to the active site for enzyme through a variety of interactions such as ionic bonding or hydrogen bonding or van der Waals forces or dipole-dipole interaction. And the second function is to provide functional groups that will attack the substrate and carry out the chemical reaction. Now this is the basic information. Now we will see the interaction of drug and enzyme. We can see here this is an enzyme in which this is the active site where the substrate will come. So substrate should have the same shape so that it will perfectly fit in the enzyme holding substrate enzyme. Okay. So drug inhibit any one of the mentioned activities, and this can block the binding site of the enzyme and prevent the binding of substrate. So it can inhibit the catalytic activity of the enzyme, and those are called as enzyme inhibitors, meaning they prevent the activity, and they inhibit the attachment of substrate of on active site of the enzymes in two different ways. So they compete with the natural substrate for their attachment on the active sites, and they are called as competitive inhibitors, meaning they will compete with the natural substrate, okay, and they will go and they will attach in their place. So they are called as competitive inhibitors. And some drugs, they do not compete with them. So what they do, they bind to a different site of enzyme, and that is called as allosteric site. So this binding of inhibitor changes the shape of the active site. So we can see here shape in this case and shape in this case, they are totally different, okay, because of the allosteric site. Then receptors as a drug targets. So they are the proteins that are crucial to body's communication process. So receptor proteins are embedded in the cell membrane in such a way that their small part possessing the active site projects out of the surface of the membrane and opens on the outside regions of the cell membrane. So we can see here the binding site of the receptor and interior of the cell. So here message between neurons and between the neurons to muscles is communicated through certain chemicals, and they are called as chemical messengers. So this gives message to the cell without entering into the cell. Then drugs that bind to the receptor side and inhibit the natural function are called as antagonists. So drugs which bind to the receptor and inhibit the natural function, they are called as antagonist. And the drugs which mimic the natural messenger by switching to that receptor, they are called as agonist. So these are very important, antagonist and agonist. Then therapeutic action of different classes of drugs. So here we will see different classes of drugs which help in curing the diseases, some common diseases. So here first of all we will see antacids. Now we all are familiar with antacids. We have studied this in our lower classes also. When there is excess of acid produced in the stomach, we take antacid to neutralize it. So basically antacid is a base which is used, okay, so major component is a base. So we will see which antacids are important to us. So acidity was administration of sodium hydrogen carbonate or a mixture of aluminium and magnesium hydroxide. So magnesium, this is mostly used, okay, to treat this. So here a major breakthrough with the treatment of hyperacidity came through discovery according with the chemical histamine stimulates the secretion of pepsin and hydrochloric acid in the stomach. So the drugs like cimetidine, which is also called as tegamet, was designed to prevent the interaction of histamine with the receptors which are present in the stomach wall, and it resulted in release of lesser amount of acid. Then again one more drug named ranitidine, which is called as Zentec, was discovered. So these are used to prevent the acidity or reduce the acidity. Then next is antihistamines. Histamine is a potent vasodilator. So it contracts the smooth muscles in the bronchi and gut and relaxes the other muscles. So here which drugs are important here as antihistamine? So synthetic drugs like brompheniramine, which is also called as dimetab, and terfenadine, which is called as celdine, they act as a antihistamines. Then next is neurologically active drugs, in which first is tranquilizers. Tranquilizers and analgesics, they are neurologically active drugs. That means they affect the message transfer mechanism from nerve to the receptor. So in this, they are used for the treatment of stress. Why tranquilizers are used? They are used for the treatment of stress, even mild or even severe mental disease. They relieve anxiety, stress, irritability and excitement by inducing a sense of well-being. Then example of tranquilizer is noradrenaline, and Then we have antidepressant drugs. So antidepressant drugs such as iproniazid and phenelzine, they are drugs to treat the depression, called as antidepressant drugs. Then some tranquilizers, namely chlordiazepoxide and meprobamate, they are mild tranquilizers suitable for relieving tension, and equanil is used in controlling depression and hypertension. The names of these drugs are very important as they ask for 1 mark question from this. Actually only 2-3 marks will be there for this chapter, but these are very important, the names. Okay. Then next we have derivatives of barbituric acid, that is veronal, amytal, nembutal, luminal and secondal constitute important class of tranquilizers. So they are called as barbiturates. Barbiturates are hypnotic. Hypnotic means they produce sleep. So some other substances used are Valium and serotonin. Then we'll move on to analgesics. Analgesics are the drugs which reduce or abolish the pain without causing impairment of consciousness, mental confusion, incoordination or paralysis or some other disturbances. So analgesics are of two types, non-narcotic and narcotic drugs. What are non-narcotic? Non-narcotic means they are non-addictive. So for example, we have aspirin. Aspirin and paracetamol belong to the class of non-narcotic analgesics, because they inhibit the synthesis of chemicals called as prostaglandins, which stimulate the inflammation in the tissue and cause the pain. Then we have antipyretic. Antipyretic means the drugs which are used when you have fever, that is to reduce the temperature, preventing platelet coagulation. Then narcotic. Narcotic means they are basically addictive drugs, and here examples are morphine. Morphine is one of the important example here. Then it relieves the pain and produce sleep. Then in poisonous doses, these produce stupor, coma, convulsions and ultimately death. Then we have antimicrobials. Under that, antibiotics. In that, antiseptics, disinfectants. So we will see antibiotics first. They are the drugs which are used to treat infections because of their low toxicity for humans and animals. So it is used to treat infections because of their low toxicity for humans and animals. That means their toxicity is only towards the microorganisms or in the microorganism, and initially they were classified as the substances produced by microorganisms, that is bacteria, fungi and molds. Then antibiotic now refers to a substance produced wholly or partly by chemical synthesis, which is in low concentration and antibiotics inhibits the growth or destroys the microorganism by intervening in the metabolic processes. So we have examples of antibiotics here, that is arsphenamine and salvarsan. Then Paul Ehrlich, he got a Nobel Prize for Medicine in 1908 for this discovery. Salvarsan is toxic to human beings. Its effect on the bacteria spirochete, which causes syphilis, is much greater than on human beings. Then we have under antibiotics, we have two types, bactericidal and bacteriostatic. Now these two are very important, their meaning as well as their examples. Bactericidal means they are having antibiotics which are having killing effect. They directly kill the bacteria, and bacteriostatic means they inhibit the growth of bacteria or microbes. So examples of bactericidal is penicillin, aminoglycosides, ofloxacin, and bacteriostatic erythromycin, tetracycline and chloramphenicol. Then under this we have two types, broad spectrum antibiotics and narrow spectrum antibiotics. Now what are broad spectrum? Antibiotics which kill or inhibit a wide range of gram positive and gram negative bacteria are called as broad spectrum antibiotics, and the antibiotics which are effective only against the gram positive and gram negative bacteria are narrow spectrum antibiotics. if effective against single organism or disease, then they are referred to as limited spectrum antibiotics. So narrow spectrum, we have an example which is a penicillin G. It has narrow spectrum effect. Then ampicillin and amoxicillin are synthetic modifications of penicillins, and they are broad spectrum. So these are the examples of broad and narrow spectrum antibiotics. Then next we have chloramphenicol, which is also a broad spectrum antibiotic, which is absorbed from a gastrointestinal tract, and hence it can be given orally in the case of typhoid, dysentery, acute fever and urinary infections. Then next we have antiseptics and disinfectants. So antiseptics, they are applied to the living tissues. For example, Dettol that we use, it is an antiseptic. So that can be applied to the living tissues, such as wounds, cuts, ulcers and diseased skin. Examples: furacin, soframycin. Then commonly used antiseptic is a Dettol, which is a mixture of chloroxylenol and terpineol. Now this is very important for half or 1 mark question. Chloroxylenol, terpineol, by mixing this we produce Dettol. Then bithionol is added to soaps to impart the antiseptic properties. Then iodine is also a powerful antiseptic, and its 2-3% in alcohol is called as tincture of iodine. Then iodoform is used as an antiseptic for wounds. And next we have disinfectants. Now these are exactly opposite to the antiseptics, but only in one case, that is, it is applied to the non-living things or inanimate objects, so such as floor, drainage system, instrumental. So they act as a antiseptic. Some substances, they act as an antiseptic as well as disinfectant. So 0.2% solution of phenol is an antiseptic, while 1% is disinfectant. Then next we have anti-fertility drugs. So the increased population, it has caused many social problems in terms of food resources, then environmental issues. And to control this, we have population is required to be controlled. So that's why the concept of family planning, that has led to the concept of family planning. So that's why anti-fertility drugs, they play very important role in controlling the population. So birth control pills, they contain a mixture of synthetic estrogen and progesterone derivatives. So these compounds are hormones which are known as progesterone suppresses ovulation, and synthetic progesterone derivatives are more potent than the progesterone. Ethinodrone is an example of synthetic progesterone derivative and used as an anti-fertility drug. An estrogen derivative which is used as a combination with progesterone is called as ethylene estradiol, which is novestrol. So these are the synthetic drugs which are used here in place of the hormones. Then next we will see chemicals in food, in which we have different types, that is food colors, flavors, then emulsifiers, stabilizing agents, antioxidants, preservatives, then nutritional supplements such as minerals, vitamins, amino acids. So we will start with the artificial sweetening agents here. Here each point is very important because they ask for 1 mark. Name the following. So natural sweeteners, that is sucrose, add to calorie intake, and therefore many people prefer to use artificial sweeteners. So we will start from the saccharin. Saccharin is the very first artificial sweetening agent and used as a sweetening agent ever since it was discovered in 1879. It is about 550 times as sweet as cane sugar. Okay, so this information or these details we need to know about saccharin. Then next we have, okay, in this table we will see aspartame. Aspartame is 100 times sweeter, saccharin is 550, sucralose is 600 and allitame is 2000. So aspartame is the most successful and widely used artificial sweetener. It is roughly 100 times as sweet as cane sugar, and here what you need to remember is use of aspartame is limited to cold foods and soft drinks because it is unstable at cooking temperature. So this is the important point of aspartame. Then Alitame is a high potency sweetener because it is 2000 times sweeter than the cane sugar. Then it is more stable than aspartame in case of the temperature. So the control sweetness would difficult while using it. Then sucrose is the last one. Its appearance and taste are like sugar and stable at cooking temperature. Then next we have food preservatives. So in food preservatives, the commonly used preservatives are table salt, sugar, vegetable oils, then sodium benzoate. Then sodium benzoate is used in limited quantities and is metabolized in the body. And salts of sorbic acid and propanoic acid are also used as a preservatives. Then about cleansing agents, we will study about detergents and soaps. So soaps, they are the detergents used since long time, and soaps are used for cleaning purpose. So soaps are actually, they are the sodium or potassium salts of long chain fatty acids. For example, stearic, oleic and palmitic acids. Soap containing sodium salts are formed by heating fat, that is glycerol, ester or fatty acid. So this reaction of soaps containing sodium salts are formed by heating fat with aqueous sodium hydroxide solution, and this reaction is called as saponification. In this, esters of fatty acids are hydrolyzed and the soap obtained remains in colloidal form. Then we have types of soaps. First of all, toilet soaps. They are prepared by using better grades of fats and salts and oils and taken care to remove the excess alkali. Color and perfumes are added to make the soaps more attractive. Then soaps that float in water. They are made by beating tiny air bubbles before their hardening. And transparent soaps are made by dissolving soap in ethanol and then evaporating in the excess solvent. In medicated soaps, substances of medicinal value are added, and in some soaps deodorants are also added. Shaving soaps contain glycerol to prevent the rapid drying, and also rosin is added while making them. Form sodium rosinate and leathers fell. Then soap chips are made by running a thin sheet of melted soap into a full cylinder and scraping off the soaps in small broken pieces. Then this is very important, why soaps does not work in hard water. So hard water actually contains calcium and magnesium ions. So when these ions, when the soap is used in hard water, these ions form insoluble calcium and magnesium respectively when sodium or potassium are dissolved in hard water. So this separate, they just come in water and are useless as cleansing agent. So these hindrance are to, in fact these are hindrance to good washing. So in hard water we cannot make good use of that soap. And also hair washed with hard water looks dull because of this sticky precipitate. Then synthetic detergents, they are cleansing agents which have all the properties of soaps. So we will talk about two main types here, anionic and cationic detergents. So anionic are sodium salts of sulfonated long chain alcohols or hydrocarbons, and here we need to know about their example. So anionic detergents, we have main example here, that is sodium lauryl sulfate, and here anionic part is involved in the cleansing action. Then they are used in household work. Anionic detergents are also used in toothpaste. Then cationic detergents, now they are quaternary ammonium salts of amines with acetates, chlorides and bromides. So example is cetyl trimethyl ammonium bromide, and they have germicidal property and expensive, therefore they are of limited use. Then last we have non-ionic, they do not have any iron in their constitution, and one such detergent is formed when we react stearic acid and polyethylene glycol. Okay, then yeah, with this we finish this chapter. So from this chapter, which is of only minimum 2 and maximum 3 marks, you can expect the questions from food preservatives, from this artificial sweeteners part, then antibiotic, analgesics, broad spectrum, narrow spectrum, then antibiotics, bacteriostaticidal, then about cationic anionic detergent, soap. So only question comes from this part, that is only for 2-3 marks. Name the following, match the following, fill in the blanks. So yeah, so these points you should remember from this chapter. Okay, with this I finish this chapter. And I will come with the solution part of the papers and FAQs in the next video. Thank you.